Hello class, let's learn about chemical equations and stoichiometry. Balance the following equation. You have to remember few rules. Number 1, balance one atom at a time. Number 2, if an atom is in 2 or more reactants or products, save it for last. As an example, hydrogen. If polyatomic ion remains intact, treat it as a single unit. So let's start with calcium. You can see you have one calcium in the reactant side and one calcium in the product side. So it is good. Let's go to oxygen. You have two oxygens in reactant side and one oxygen is in water. So we are going to add 2 here. That makes you have 2 oxygens in the product side as well. Now let's go to chlorine. You have one chlorine here and 2 chlorines here. So we are going to add 2 to this side. Now let's look at the hydrogens. You have 2 hydrogens here, 2 hydrogens here. That makes you have total of 4 hydrogens in the reactant side. And in this side you have 4 hydrogens as products. So let's look at the whole equation again. You have one calcium, one calcium. You have 2 oxygens in this side and 2 oxygens in the product side. And then you have 2 hydrogens here, 2 hydrogens here. That makes 4 hydrogens. Here you have 4 hydrogens, 2 chlorines and 2 chlorines. Write balanced equation for following. Calcium chloride and sodium carbonate react to produce calcium carbonate and sodium chloride. First, you need to figure out the molecular formula for your reactants and products. We've done this in chapter 3, and if you need a refresher, go back to chapter 3. Let's take calcium chloride. Calcium makes 2 plus cations and chlorine makes -1 anion. So we do the crossover method and this is calcium chloride. Sodium carbonate, sodium makes +1 ions and then carbonate. This is a polyatomic anion. It has a 2- charge. So we do the crossover method and Na2CO3 is your sodium carbonate. Calcium carbonate, calcium makes 2 plus ions and carbonate has 2- charge. So this will give you calcium carbonate. Sodium chloride, sodium has +1 charge and chlorine has -1 charge. So this is your formula for sodium chloride. Let's write the chemical equation. And then we have to balance this equation. So as the rule number 1 say, we are going to start with just one by one. So let's start with calcium. We have one calcium in the reactant side and one calcium in the product side, and calcium is good. Let's go to sodium. So this side you have 2 sodiums and this side you have just 1 sodium. So we are going to add 2 here. And then let's go to carbonate anion. So the rule number 3 says if the polyatomic anion is intact in reactants and products, we count it as 1 unit. So you can see carbonate didn't change when it goes to the product side. So we are going to count carbonate as 1 unit. We have 1 carbonate here, 1 carbonate here. And then we are going to chlorine. We have 2 chlorines in this side and 2 chlorines in this side. Balance the following equation. So the equation has given, and when you look at the equation, you see the polyatomic anions, sulfite and phosphate, and they did not change when they go to the product side. So we are going to treat them as single units. Let's look at sodium. You have 2 sodiums in this side and 3 sodiums in this side. So we are going to add 3 to this side, making 6 sodium, and 2 to this side, making 6 sodium. And sulfide. Now we have 3 sulfides in this side and 1 sulfide in this side. So we are going to add 3 to this side. Now let's count number of hydrogens. We have 3 hydrogens here and we have 6 hydrogens here. So we are going to multiply this by 2. Now we are going to go to the phosphates. We have 2 phosphates in this side and 2 phosphates in this side. As the final step, you are going to count all the cations and anions in the equation. We have 6 sodiums, 6 sodiums, 3 sulfides, 3 sulfides, 6 hydrogens, 6 hydrogens, 2 phosphates, 2 phosphates. This is your balanced equation. Let's practice more. You have given this equation. Let's start with aluminum. You have 1 aluminum in this side and 2 aluminums in this side. So we are going to use 2 in this side. Zinc 1 and zinc 1. It's good. And 1 oxygen and 3 oxygen. So we are going to multiply by 3, and by doing that you made 3 zincs in this side. So we have to go back and add 3 to this side. Let's count the whole equation now. 2 aluminums, 2 aluminums, 3 zinc, 3 zinc, 3 oxygens, 3 oxygens. Let's go to sodium. 1 sodium, 1 sodium. It's good. And let's count the hydrogens. 2 hydrogens, and here in this side you have 1 plus 2, that means 3 hydrogens. So how do we balance this equation? We are going to add 2 here, and that makes that you have 2 sodium as well, and you are going to add 2 sodium into this side. By adding 2 hydrogen here, you are going to make this to 2 oxygen as well. So you go back and add 2 to your water. Now let's count the whole equation. 2 sodium, 2 sodium, 4 hydrogens, 2 plus 2, 4 hydrogens, 2 oxygens, 2 oxygens. This is your balanced equation. So let's go to this equation. You have 2 nitrogens here and you have 1 nitrogen here. So we add 2 in front of nitrogen dioxide. That makes your oxygens 5 in this side and this side. 4 plus 2, 6. Now what we're going to do is we are going to multiply 2 by this side, and let's see what happens. If you add 2 to this side, it makes 4 nitrogens. So you are going to do 4 here, and that changes your number of oxygens. Let's count the number of oxygens. So in this side now have 4 nitrogens and 10 oxygens. Now in this side we have 4 nitrogens and 8 plus 2, 10 oxygens. So this is your balanced equation. In this case, we take chromium first, 1 chromium, 1 chromium, and you have 2 chlorines and you have 6 chlorines. So we are going to simply multiply this by 3. So this is your balanced equation. Let's do one more example. So let's start with potassium, and 1 potassium, 1 potassium, and you can see this polyatomic anion did not stay intact. So this is ClO4, this is ClO3. So we are going to treat one atom at each time. So let's count the chlorines. 1 chlorine, 1 chlorine. Now the problem is with the oxygen. So we have 4 oxygens this side, 3 oxygen plus 2, 5. So how do we balance? We are going to add 2 to this side. That will make you have 8 oxygens. And if you have 8 oxygens, we already have 2, that means we are in need of 6 oxygens. So we are going to add 2 to this side. That makes this equation balanced. So let's count the whole equation. 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines, 8 oxygens, and then in this side 6 plus 2, 8 oxygens. Now you know how to balance the equations. Let's do some calculations using stoichiometry. How many grams of sodium chloride can be made from 10 grams of chlorine? First, we have to write a balanced equation. Sodium plus chlorine produce sodium chloride. 2 sodium, 2 sodium, 2 chlorines, 2 chlorines. The equation is balanced. When you balance the equation, you see a numerical relationship between reactants and products. When we count this relationship in moles, we call it stoichiometry, and these numbers are called stoichiometric coefficients. This means 2 moles of sodium reacts with 1 mole of chlorine and produce 2 moles of sodium chloride. At this point, you know how to calculate molar mass of sodium chloride and molar mass of chlorine. And then from the stoichiometric coefficient, we know 1 mole of chlorine reacts to produce 2 moles of sodium chloride. Let's do dimensional analysis. First, you have to find the number of moles of chlorine. Then you are going to convert it to number of moles of sodium chloride. And then in this part, you are going to convert this to number of grams of sodium chloride. So we start with 10 gram of chlorine, and by the molar mass we know 1 mole weighs 70.90 grams chlorine. We use this fraction in such a way that it can cancel gram chlorine to gram chlorine. Now we use the stoichiometric relationship. So we know 1 mole of chlorine produces 2 moles of sodium chloride. By doing that, we have the number of moles of sodium chloride. Now we are going to find the grams. For that, we need molar mass of sodium chloride. We know 1 mole of sodium chloride weighs 58.44 grams. So your answer is 16.5 grams of sodium chloride. Let's do one more example. Let's go to part A. This is the equation. How many moles of hydrogen would be needed to produce 45 moles of ammonia? So you have nitrogen and reacts with hydrogen, produce ammonia. So you need to check whether the equation is balanced. 2 nitrogens, 2 nitrogens, 3 hydrogens and 3 hydrogens. Equation is balanced. When we ask the questions in moles and it relates to moles, these are the easiest type of calculations to do. And from the stoichiometric ratio, we know 3 moles of hydrogens produce 2 moles of ammonia. So we are going to do the dimensional analysis. We are going to start with 45 moles of ammonia. And we know by the stoichiometric ratio, 2 moles of ammonia requires 3 moles of hydrogen. So your answer is 67.5 moles of hydrogen. How many moles of nitrogen would be needed to react with 4.50 mole hydrogen? So we take the stoichiometric relationship. 1 mole of nitrogen needs to be reacts with 3 moles of hydrogen. So we start with 4.50 mole hydrogen and we know 3 moles of hydrogen reacts with 1 mole of nitrogen. Your answer is 1.50 moles of nitrogen. Part C. How many grams of ammonia could be produced from 225 grams of hydrogen? When you have asked the grams, then you have to consider the molar mass as well. So by looking at this information, we can see that 3 moles of hydrogen gives off 2 moles of ammonia, and your molar masses are for hydrogen 2.016 grams, for ammonia 17.03 grams. So we start with 225 gram hydrogen. First we have to find the number of hydrogen in this amount. Then we are convert it to the number of moles of ammonia. And then we are in the next step, we are going to convert it to number of grams of ammonia. So we start with 225 grams hydrogen, and by the molar mass we know 1 mole weighs 2.016 grams hydrogen. So you can see gram hydrogen to gram hydrogen cancels out. We are going to end up with moles hydrogen. Next step is we are going to use the stoichiometric relationship. We know 3 moles of hydrogen is needed to produce 2 moles of ammonia. You can see mole hydrogen to mole hydrogen cancel out. In this part we have the number of moles of ammonia. So in this part we are going to convert it to mass. For that we are going to use molar mass of ammonia. We know 1 mole of ammonia weighs 17.03 grams. So this cancels out to this. You are going to end up with grams ammonia. Part D. How many kilograms of nitrogen would be required to react with 3.5 kilograms of hydrogen? Now we have to incorporate the grams to kilograms conversion as well. From the stoichiometric ratio, we know 1 mole of nitrogen is required to produce 1 mole of nitrogen is required to react with 3 moles of hydrogen. And then you are going to use the molar masses as well. 1 mole of nitrogen weighs 28.02 grams. 1 mole of hydrogen weighs 2.016 grams, and then you know 1000 grams is equal to 1 kilogram. Let's go to the dimensional analysis. We start with 3.4 kilogram of hydrogen and we are going to convert it to grams. We know 1 kilogram equals to 1000 grams. So now you see kilograms to kilogram cancels out. Now we have the hydrogen in grams. Now we need to find the number of moles of hydrogen. For that we are going to use the molar mass of hydrogen. We know 1 mole of hydrogen weighs 2.016 grams. You can see gram hydrogen cancels out. Now we are going to use the stoichiometric ratio to find the number of nitrogen required to react with this much of hydrogen. So we know 3 moles of hydrogen are required to react with 1 mole of nitrogen. Now we are going to convert this amount into the grams of nitrogen. For that we are going to use the molar mass, and then again we have the answer in grams, but it asks how many kilograms. Then again we have to convert the number of grams of nitrogen to kilograms. So we are going to use 1000 grams of nitrogen over 1 kilogram. So your answer is 15.8 kilograms. This is the end of this session, and let me know if you have more questions. Thank you.